ladies and gentlemen. We are here going to pursue the general ability part of the computer science department of GATE 2022 question paper. So let us go through the problems. The first problem, this is of verbal ability. Now the fare means the cost of going, bus ticket, train ticket, etc. Fare. So the spelling of that is F-A-R-E is too high for it to be considered fair. Fair means okay. Unfair, the opposite of unfair is fair. So that spelling is F-A-I. So let us see which option has these spellings, and we can see that it is option number D. So that is the correct answer. Let's go on to the next one. A function yx is defined in the interval 0, 1 on the x-axis as yx equal to 2 if x is greater than equal to 0 but less than 1/3, yx equal to 3 if x is greater than equal to 1/3 but less than 3/4, and yx equal to 1 if x is greater than equal to 3/4 but less than equal to 1. So they have asked you which one of the following is the area under the curve for this interval 0, 1 on the x-axis. How do we do it? Quite simple. The coordinate system, and this is 0. Let us suppose this is 1. Let's assume that. And here let us suppose this is 1, this is 2, and this is 3. On the x-axis and on the y-axis. Now 1/3 would approximately be somewhere on this. 3/4 would be somewhere around somewhere around this. Very difficult to be accurate, but I hope you understand. So like this. So we say that yx is 2 when x is greater than equal to 0 but is less than 1/3. So we can say that this is the portion. Now this line, it appears to be tentatively cutting on 1/3, but obviously since it's just less than 1/3, so it's not exactly on 1/3. But showing that is very difficult in a manual diagram. So I hope you understand that. Now yx is equal to 3 when x is at 1/3. So this is actually on 1/3. And till 3/4. So somewhat of this. And x is yx is equal to 1 when x is greater than equal to 3/4 and less than equal to 1. So yx is 1, so this would be somewhat around this. So what we are required to find is the area of this striped portion. How do we find the area? Pretty simple. These are all rectangles individually. So the area of the first rectangle would be 1/3 into 2. The area of the second rectangle would be, see, 3/4 minus 1/3, which will give us this length multiplied by 3. And the third portion would be, see, 1 minus 3/4, that will be this portion multiplied by 1. Now the total area would be the summation of these. So let's find out what's the value of this. So this is 2/3. Now 3/4 minus 1/3. Simple. It is 9 minus 4, that is 5/12. So 5/12 into 3 is 5/4. And 1 minus 3/4 is 1/4. So 1/4 into 1 is 1/4. Now 5 by 4 plus 1 by 4 is 6 by 4. 6 by 4 plus 2 by 3. So 2 by 3 plus 6 by 4 can be said to be 3 by 2. So that is 6, and 4 plus 9, that is 13. So 13 by 6 is the area, and we can see that it is there given in this option. So this is how you find it. It's pretty simple one. This is a polynomial that is given. Let R be the root of equation x square plus 2x plus 6 equal to 0. Fine. So since R is the root of this, so R must satisfy this equation. So we can write that R square plus 2R plus 6 is equal to 0 is true. And hence we can say that R, see, let us observe this, that this can't be middle term factorized, because 6 is either 6 into 1 or 3 into 2. So it can't be middle term factorized. If we applied Sridhar Acharya's rule that the root is minus b plus minus root over of b square minus 4ac by 2a, that would be a very complex structure. So it is not in the best of interest of us to find out what R is. We could have, but that would not be in the best of interests, because putting that here and multiplying them, you would be taking somewhere around 20 minutes for this sum itself. At least I would be taking that. So instead of doing that, let us find out some intelligent avenues of finding this out. Well, one thing we can do, we can say that this is true. R square plus 2R must always be equal to minus 6. Now look at this expression. If you multiply these two, so what do we get? R square plus 5R plus 6, right? And if we multiply these two, you could have selected other pairs also, but I went on in the, one by one fashion, one after the other fashion. So this would be R square plus 9R plus 20. Now we know R square plus 2R is equal to minus 6. So we can say now that this is equal to R square plus 2R plus 3R plus 6. And this one is R square plus 2R plus 7R plus 20. We can write that, and let us substitute minus 6 for these two cases. So what does this become? See, 3R this becomes, because 6 and minus 6 cancel each other. 3R into this becomes 7R plus 14. And here we can make things simpler by saying that 7 goes out common. So this is 21R, R plus 2. Now let us put R inside. So 21 R square plus 2R, which again is minus 6. So the result is 6 into 1 is this, and 6 into 2 is 12. So let's see what an easy way to find this out. So whenever you get something where you can't find the value, always try these methods. These are very, very handy methods. So the option will be this one. This was a good sum. Let's go on to the next one. This is a logical reasoning question. Given below are 4 statements. Statement 1. All students are inquisitive. I hope you understand inquisitiveness. Inquisitive means they have an interest, they want to know everything, curious type of, which is a good quality. All students are inquisitive. Statement 2 says some students are inquisitive. Statement 3 says no student is inquisitive. Statement 4 says some students are not inquisitive. Okay. From the given 4 statements, find the 2 statements that cannot be true simultaneously. They can never be true if they are placed together, assuming that there is at least one student in the class. So studying there is a very simple one. I hope everybody will agree that if statement 1 were said and along with it statement 3 were said, they totally clash against each other. No two statements clash against each other the way these two do, because they're directly opposite to each other. The others, they are leaving some space. Some students are inquisitive means some students are not inquisitive. Some students are inquisitive for one student. It means that that one student is inquisitive, so no student is inquisitive. These two will be okay. Some students are inquisitive for one student, and all students are inquisitive for one student. They are the same. So all the other combinations are okay, but these two will never be okay. So statement 1 and 3 can never be placed together. And we find out that option A is the one that says that. So this is the answer. A palindrome, I'm sure we all know what a palindrome is, but they have also given it is a word that reads the same forwards and backwards. For example, adda. If look it from here, it's adda. If look from here, it's also adda. So this is a palindrome. A palindrome can also be like this. AD, MDA. Mane, this doesn't have any word or you just put M. So you see, if you look at this, whatever this is it. So it's not necessary that every letter must be twice. So not necessary. So these are palindromes. In a game of words, a player has the following two plates painted with letters. So these are already with the players. From the additional plates given in the options, which one of the combinations of additional plates would allow the player to construct a 5-letter palindrome? So a palindrome must be constructed like this. This is a 5-lettered one. And because it is odd-lettered one, there must be one letter that will be always single. It has to be single. Okay, this we must take care. And the others must be double and double. Had it been even-lettered palindrome, all the letters would have had to be double, right? So, which one of the combinations of additional plates would allow the player should use all the 5 plates exactly once. The plates can also be rotated in their plane. Okay, so you can move it very clearly. This is D, so this doesn't look like a natural D, so you can rotate it if you want. Now look here, if it is A, 2 D's are there. If you bring in 2 D's, then the number of D's will be 3, which does not allow for a palindrome. Okay, so A is cancelled. Let us look at B. It is R, A, R. And we would say that bringing this in allows us an extra A and allows us 2 extra R's. So we could jolly well say R, A, D, A, R. See, this is a fantastic palindrome. So number B would be the correct one option. In an exam, if we go on, if we find the correct one, then no use in wasting time to look at the others because there will be only one correct option. But since this is a practice session, let us look at the others. You see, A and D are already there, and you have Z, E, D. So D is twice, but then A, E, and Z are unique and single. They can never make a palindrome. And along with A and D, you get 3 entirely different stuff. So 5 different letters. So you can never make a palindrome in that. So number B still stands out correct. Hence, that's the right option. Okay, this is a critical reasoning question. Ladies and gentlemen, we must understand that critical reasoning is a type of verbal ability question wherein vocabulary, its meanings, its correct understanding is very important. And there is one more thing that we must keep in mind, that even if the passage of that critical reasoning after reading appears that it is incorrect or deviates from the actual fact whatsoever, but we can do nothing about it. As long as we are solving this critical reasoning question, that passage is what is true. So everything depends upon that passage. We cannot add our facts or our own judgment to that. This is a very important thing which we must remember, because the maximum mistakes happen there. Okay, now let us see what this passage says. Some people believe that what gets measured improves. Some others believe that what gets measured gets gained. One possible reason for the difference in the beliefs is the work culture in organizations. In organizations with good work culture, metrics help improve outcomes. Metrics means facts, data, measurements. Metrics help improve outcomes. However, the same metrics are counterproductive, means do not improve outcomes in organizations with poor work culture. Which of the following is the correct logical inference? Inference means conclusion based on the information in the above passage. Let us look at the options. Metrics are useful in organizations with poor work culture. It directly says the opposite with what has been said in the passage. See, in poor work culture, the metrics are counterproductive. So this can never be a correct logical conclusion. Next, metrics are useful in organizations with good work culture. This is exactly what has been said here. In organizations with good work culture, metrics help improve outcomes. So this will be our correct choice. In the exam, no need to see further. But because this is not an exam practice session, so let us look at the other options. Metrics are always counterproductive in organizations with good work culture. Obviously, I hope you are understanding that it's again saying the opposite. So it's not a logical conclusion. And metrics are never useful in organizations with good work culture. No. In good work culture, metrics help you improve outcomes. So improvement of outcomes is usefulness. So this is also false. So we find after seeing all the options that this option B still remains. So that's the right one. In a recently conducted national entrance test, boys constituted 65% of those who appeared for the test. Okay, so we are talking here of the appearance for the test. Girls constituted the remaining candidates. So girls would be 35%, and they accounted for 60% of the qualified candidates, which means who passed out if it's an exam. So girls 60% passed out, which means boys that passed out is 40%. 40% boys passed. Or rather, I should have used the word qualified. It's okay. Which one of the following is the correct logical conclusion based on the information provided in the above passage? So this is a critical reasoning question, but based on quantitative things. Let us see. Equal number of boys and girls qualified. Absolutely wrong, because 60% of the girls qualified and 40% of the boys passed out. Okay. So, I mean, rather my English application was wrong. 60% of the qualified candidates were girls, and hence 40% of the qualified candidates were boys. So boys and girls can never be equal. So this is not correct. Equal number of boys and girls appeared for the test. can never be. Girls were 65% of those who appeared for the test, and boys, rather boys were 65% of those who appeared for the test, and girls were 35% of those who appeared for the test. So they can't be equal. The number of boys who appeared for the test is less than the number of girls who appeared. Directly opposite they are saying. If 100 appeared, then 65 were boys and 35 were girls. So 65 were boys and 35 were girls. So the number of boys will be more. They are saying less here. So this is also not the correct inference. By default, then the fourth one must be correct. But then in an exam, you would just take the fourth one. You may not waste time in reading it. But here, it's a practice session. Let us see. The number of boys who qualified the test is less than the number of girls who qualified. Absolutely. See, the girls who qualified were 60% and the number of boys were 40%. So the girls were more. So this is the correct option. Question from modern mathematics, probability. Let's see. A box contains 5 balls of same size and shape, is identical appearance. 3 of them are green colored balls and 2 of them are orange colored balls. So it's something like this. These are the 5 balls. Balls are drawn from the box one at a time. If a green ball is drawn, it is not replaced. Green ball is not replaced. If an orange ball is drawn, it is replaced with another orange ball. Okay. So they have asked you, the first ball is drawn. What is the probability of getting an orange ball in the next draw? How to solve this? The first draw, what can be it? Can be of 2 types. One is a green draw and the other is an orange draw. Now, had it been a green draw, the probability of picking up a green ball would have been 3 by 5 because the total number of balls were 5 and the total number of green balls were 3. Having picked up the green ball will go in my pocket. It won't be replaced. So now in the bag or box, there are now 4 balls left. And from the 4 balls, I am picking up an orange ball because that is whose probability is being asked. So the probability of picking up an orange ball would be, there are 2 orange balls out of the 4 balls left. So 2 by 4. Now these are simultaneous activities, so there will be a multiplication. So the first draw, if it is green, so this will be the case. Now what if the first draw is orange? Now if the first draw is orange, the probability of picking up an orange is 2 by 5 because out of 5 balls, I am picking up 2 balls. Now, since I have picked up an orange ball, I again replace that orange ball in the box. So the total number of balls in the box remain 5. And in the second draw, I will have to again pick up an orange ball. So I will again do it in 2 by 5 ways. I mean, the probability of doing it is 2 by 5. Simultaneous activities, so I will be multiplying it. So this is the probability had the first pick been an orange. Now both of these are independent events, but they have to be considered. So I will add them up. So the result would be 3 by 5 into 2 by 4 can be said to be half. So this is 3 by 10. And this would be 4 by 25. So 3 by 10 and 25. The LCM would be 5, 2 and 5. So 50. So 5 threes are 15 plus 8 is 23. So 23 by 50 is the probability of getting an orange ball in the next draw with the criteria given. Option number B. Right? Let's go to the next one. The corners and midpoints of the sides of a triangle are named using the distinct letters P, Q, R, S, T, and U, but not necessarily in the same order. Okay. Consider the following statements. The line joining P and R is parallel to the line joining Q and S. So in how many ways can this be possible? Let us check. Suppose this is a triangle. It has not been given it is an equilateral triangle or anything, but the shape came out like this. So this is just a random triangle. And these are the midpoints of the sides because they have been accounted for. So the line joining PR is parallel to the line joining QS. So one of the cases could be this is P, this is R, this is Q, and this is S. This could be the case. But then there is no guarantee that P will be on the left and R will be on the right. So we can also say this could be R and this could be P, and the same vice versa pattern here. But this is one case. This would be P. Now let's go if there are any other cases. Lots of cases will be there, can be seen. So if this is the triangle or this is the case, so another case would be Q and S are here. This is Q and this is S, and this is P and this is R. But then like the previous case, this S could lie here also, and hence Q would lie here, and R could lie here also, and then P would lie here. So this could be also a case. Now there can be another case. See, PR is parallel to QS. So we can say that this is P and this is R. However, this is Q and this one is S. See, PR is parallel to QS. Okay. But then the opposite case can also be true. I mean, they can reverse themselves. So you see, and here also. So this can also be a case. So another scenario would be the opposite. See, this is Q, this is S, this is P, and this is R. The reverse can also be true. So this can be S, and hence this will be Q. This can be R, and hence this can be P. See, all the cases are possible if you take into account the first condition. Any other condition? Yes, there can be two more. So say let us take this. See, this is P, this is R, and we can say this is Q and this is S. We can say that. The reverse is also true. So this is R, this is P, this is S, and hence this is Q. And likewise, this case can also happen. See, this is P, no, the opposite. So this is Q, this is S, this is P, and this is R, and hence the reverse like this. Any more cases? No, don't think so. So all the cases are covered. So we have comfortably got point 1. Let us go on to point 2. Let us take a different color so that we can understand what we are doing about point 2. P is placed on the side opposite to the corner T. Now let us look at this. P is placed on the side opposite to the corner T. Now P can only be in these two places. So the opposite corner can only be this one and this one, but P can't sit there because our condition only Q or S can sit there. So at the first instance we say because of the second point this is not valid. Looking here, P is placed on the side opposite to corner T. See, P can be here. See, whether P is here or whether it is here, P is on the side opposite to T, right? So this is perfectly valid. Let us look here. See, had P been here, then T can never be positioned. So obviously P is not here. Hence R is not here. If this is P, then this is P. So the red colors indicate what is happening due to the second point. Now here, see, had P been here, I mean here also you can say that P can be here. It's straightforward more or less. See, P is on the side opposite to T. Whether if it is on this or here, it's the same case. Now in this scenario, see, P can never be here because then opposite to PT would have been positioned, but here there is either S or Q sitting. So P can't be here, so R can't be here, so P is here, so opposite to P, this is T. And here, this is T. So the second point is perfectly fitting in. One got eliminated, the rest of them are there. Let us go on to the next one and let us do this in blue. S and U cannot be placed on the same side. Now where can U be? Obviously, let us look here. Where can U be? See, there is only one position vacant, so this must be. Let us first fill in. So here U can be only here. Here U can be only here because the remaining position is U. Here U can be only here, and here U can be only here. So U we have filled in. Now S and U cannot be placed on the same side. See, this is perfectly okay. S and U are definitely not placed on the same side. So perfectly valid. See, here S and U are definitely not placed on the same side. Yes, they are actually. S can't be here because if S were here, S and U would be on the same side. So from this third point, we can understand that S is not here. Only Q can be here. So Q can't be here. And hence we get a unique scenario. Here, U and S can't be on the same side. So S can't be here. Only Q can be here. So Q can't be here. S is only here. So once again, a unique position. So all of these are happening. Now here, S and U can't be placed on the same side. See, U is here and S is here or here. So this S can't be possible. Hence here, Q is not possible. So once again, it is here with the modifications. And here, U and S can't be on the same side. So this S can't be here. So here, this Q can't be here. So you see this also happens, U and S are the same side. So all these 5 fulfill and all the different conditions are there. Now let us look at the options having all done this. By the way, the blue one was the third one. See, P cannot be placed at a corner, they have said. But well, here if you notice, P is placed at a corner, and in any one of the corners P can be placed. So this is absolutely false. If one case it is rendered false, then we don't have to look at the others, right? So it's false here. So this is not true. S cannot be placed at a corner. It is not placed on any corner. It is not placed on any corner because the corner one had to get cancelled. It is not placed at any corner. It is not placed at any corner. The corner one got cancelled. And here also it is not placed at any corner. So this is the right option. Now the moment I have got the correct option, in the exam, no need of looking at the others and wasting time. But since this is a practice session, let us go ahead. You cannot be placed at a midpoint, but you see you got placed at a midpoint. So if one point is opposite to this, then it's untrue. So this is wrong. R cannot be placed at a corner. Now you see R definitely got placed at any one of the corners. So again, this is also untrue. So even after observing all the conclusions, we can see that this one stands out. And so that is the correct option. This was a complicated one. I hope all of you understood it. Let's go on to the next one. Okay, what is this? A plot of land must be divided between 4 families. 4 families, okay. They want their individual plots to be similar in shape, though not necessarily equal in ideas, equal in area, my apologies. So shape must be same, area may not be the same. The land has equally spaced poles marked as dots in the below figure. Okay, so those dots are poles, they're standing vertically. 2 ropes R1 and R2, okay, are already present and cannot be moved. What is the least number of additional straight ropes needed? Okay, the ropes must be straight to create the desired plots. A single rope can pass through 3 poles that are aligned in a straight line. Okay, can pass through 3 poles that are aligned in a straight line, but can't pass through 4. Okay, it's the last line actually acted as a clue. See, 3 poles, the moment they say 3 poles, so it automatically came in. So you see, if one of the poles is drawn like this, one of the ropes is drawn like this, the other rope is drawn like this, and another rope is drawn like this. See, all of them are passing through 3. And you see the shape of this is exactly same. So is the shape of this and the shape of this, though of course they are different in age. So how many ropes did I need to draw? 3. So my answer would be, is the option given 3? Yes. So that's the answer. So this is a logical, this is sort of a puzzle. This was fairly simple. Let's go on to the next one. Oh, achha, we have finished. So all the questions are finished. I hope I have been able to explain them properly to you. That's it. Thank you, everybody.